Hello students, today we are going to start chapter 11, that is work and energy. We'll be doing this chapter in two parts. In part 1 we are going to discuss work and in part 2 we are going to discuss energy. There is also weight of work or power given in your chapter, but that part has been removed from your syllabus. So we are going to discuss only work and energy. Now let us understand what is work. See students, you all must have seen different types of work done in your daily life. For example, this horse pulling a cart is doing work. A man climbing the stairs does work. An engine of a moving vehicle does work. Similarly, a body dropped from a height falls towards the earth. It indicates that the earth exerts a force of attraction called gravity on the body. The gravitational force does work on it by pulling the body towards the earth. Now, work is said to be done scientifically when a force applied on a body produces motion in it. Work done in moving a body is equal to the product of force exerted on the body and the distance moved by the body in the direction of the force. Here you can see there is a box, and if we apply force on it by pushing it, and if it moves in the direction of force, then work will be done on it. Now what is force? We all know that push or pull is known as force. If we push or pull an object, we are applying force on it. And what is displacement? Change in the position of an object is known as displacement. So if we apply a force on an object and it moves, then work will be done on that object. So we can say that the work done in a moving body is equal to the product of force exerted on the body and the displacement of that body. So work done is equals to force into displacement. We can also write it like this: W is equals to F into S, where W is work done, F is force, and S is displacement. Work is a scalar quantity. It depends on direction. Work can be positive, negative, or zero. Negative work does not mean it is a vector quantity. Work done by friction is negative as the displacement is opposite to the friction. As we all know that frictional force always works on the opposite direction of the motion. So that is why work done by a frictional force is always negative. SI unit of work is Joule. As we all know that to carry out any type of work we need energy, and SI unit of energy is Joule. So we can say that the SI unit of work is also Joule. Now next is 1 Joule is equals to 1 Newton into 1 meter. As we all know that work done is equals to force into displacement, or W is equals to F into S, where W is work done and SI unit of W is Joule, F is force and SI unit of force is Newton, S is displacement and SI unit of displacement is meter. So we can say that 1 Joule is equals to 1 Newton into 1 meter. So 1 Joule is equals to 1 Newton into 1 meter. So this is the definition of 1 Joule. 1 Joule is the amount of work done when 1 Newton of force acting on a body displaces it through 1 meter. Right. So what is 1 Joule? 1 Joule is equals to 1 Newton into 1 meter. If we apply 1 Newton force on an object and it moves 1 meter, then the work done on it will be equal to 1 Joule. The CGS unit of work is erg, and 1 Joule is equals to 10 to the power 7 erg, or we can also say that 1 erg is equals to 10 to the power minus 7 Joule. For work to be done, both force and displacement must be present on a body. If a force applied on a body does not produce displacement on a body, scientifically work is not done. You can understand it like this: if a force is applied on an object and the displacement, it does not move. So the displacement will be equal to 0. So work done will be equal to force into 0, means 0. Suppose we are applying 5 Newton force on this box and this box doesn't moves, then the work done on it will be equal to 5 into 0, right? So it will be equal to 0. So if we are applying force and there is no motion in an object, then the work done on an object will be equal to 0. So you can understand it with these examples. A man holding a book on his hand in a stationary position does not do any work. Doesn't matter how many hours he is standing over there, but work done is equals to 0. Why? Because the weight of the book acting on him does not produce any displacement, right? If a man is standing here, this book is applying force on it, but work done is equals to 0. Similarly, a man is trying to push a rigid or stationary wall, does not do any work since the force applied by him does not move the wall, right? So, if we apply force on an object but there is no displacement, then the work done on an object will be equal to 0. Work done by oblique force. Force F is resolved into two rectangular components, F sin theta and F cos theta. F sin theta acting in the vertical direction does not displace the body in that direction. Therefore, work done by the component Fs sin theta is equals to 0. But F cos theta acting in the horizontal direction displaces the body in that direction. Therefore, work done is equals to W is equals to F cos theta into S, right? Because work done is equals to force into displacement. And the force that is moving this object is F cos theta. So, W will be F S cos theta. Now, work can be positive, 0 and negative. Let us understand it. The work done is positive if the force acts on the body in the direction of the motion. If we are applying force in this direction and the body is moving in the similar direction, then the work done will be equal to will be always positive. W is equals to Fs, as we all know that W is equals to Fs cos theta. Here cos theta is equals to 1 because the angle between they are moving in the similar direction. So they are almost parallel to each other. So cos theta is equals to 0 and cos 0 is equals to 1. So Fs cos theta is equals to F into S into 1. So W is equals to Fs. What did I say? Work done will be positive when force and displacement are in similar direction, because cos theta is equals to 0 and cos 0 is equals to 1. So W is equals to F into S. Next is work done is 0 if force acts on the body in the direction perpendicular to its motion. If the motion is in this direction and force is applied in this direction, then there is an angle of 90 degree. Then the work done will be equal to 0 because cos 90 is equals to 0. W is equals to Fs cos theta, Fs cos 90. Cos 90 is equals to 0, so W is equals to 0. Next is work done is negative if the force acts on the body in the direction opposite to the direction of its motion. If the body is moving in this direction and force is applying in opposite direction, then the work done will be always negative, as there is an angle of 180 degree and cos 180 is equals to minus 1. So W is equals to minus F into S. So we can say that the work done is positive when the force is acting on the similar direction of the motion or displacement. Work done is 0 if force is applying perpendicular to the direction of motion, and force and work is negative when force is applying in the opposite direction of the motion, right? We can understand them with some more examples. For example, work done by the gravitational force on a satellite is 0 because the force acts perpendicular to the direction of the motion of satellite. This satellite is moving in this direction and the gravitational force applied on it is in this direction. So there is an angle of 90 degree between them, and as we all know that cos 90 is equals to 0. So W, work done by this gravitational force, will be equal to 0. Similarly, work done by sun on the earth is 0. Again the reason is same. The motion is this. Gravitational force is acting in this direction. The angle is 190 degree. When we throw a ball vertically upwards, the work done by our force is positive because we are throwing it in vertical direction and the ball is moving in vertical direction. So, work done by us will be positive. But the work done by gravitational force will be negative since it acts in the direction opposite to the motion of ball. When the ball falls back, supposedly ball is now here. When the ball falls back, the work done by the gravitational force is positive since it acts along the direction of the motion of ball. Here is the work done by gravitational force direction, and this is the direction of displacement. So as they both are same now, so the work done by gravitational force will be positive here. So this is all for today. Thank you.